Hi, I'm Narendra Kumar, and this is going to be the masterclass about handling PII data. We will start by understanding what exactly is PII data, what are its different types, why do we need to do different techniques to handle PII data, what are the different levels or the techniques to handle the data, and for each of the level, we will understand how exactly we can do it, like how to minimize the data, how to classify it, what are the different techniques to protect the data. For these techniques also, like within pseudonymization, how to use hashing, tokenization, and the types of anonymization that we can use. And for encryption also, what different ways we can use, how we can control the access using different techniques, how we can monitor the usage or access of the data, and how we can enable the proper deletion of PII data. So all these we will understand, and at the end we will also understand how to decide which of this technique we shall use to handle the PII data properly. And we will not only cover the theoretical part. For each of the section we are going to see a demo as well, where we will handle the PII data using that specific technique on our own. This demo, it is going to be on free edition so that you can try it out yourself without any cost. And whatever notebooks or the files that I'm going to use, so everything is uploaded in this GitHub repository. The link is there in the description. And before we start, so just a quick info about myself. So as you know, I'm Narendra Kumar. I'm a senior data architect. I have 12 years of experience in IT industry with 8 years in data engineering. And I have completed the professional certification in Databricks, architect certification in Microsoft, and recently I became a Databricks certified solution architect champion as well. And during my working, I have worked on so many different projects, understood different scenarios, how we can handle PII data. I have combined all the knowledge. That is what I'm sharing in this video. I have also created very detailed videos on data engineering project with metadata framework, CI/CD with asset bundles, and I have also created multiple playlists like a complete course on PySpark, complete course on all Databricks features, interview questions, and a data engineering roadmap as well. So feel free to check these out. And if you want to stay in touch with me, send me a connection request on LinkedIn. I will accept it. Let's start by understanding what exactly is PII data. So this is the definition. So PII, it means personally identifiable information. This is any data that can directly or indirectly identify a specific individual. So what it means is that depending on the data, if we are able to find that this data belongs to this person, then that is considered as PII data. And it is of two types, direct PII and indirect PII. So direct, what it means is that if we have that single entry or single value with us, so using that single item we are able to identify who is that person. So that is called as direct PII. And examples, these are like full name, email address, phone number, SSN number, passport number. So using any of this data, we can know which person it is. So that's why it is called as direct PII. And they uniquely identify a person on its own, like having the single column itself, we can tag to one person. And indirect PII, it is still personal data, but the data single entry, it is not able to identify who is that person. But when combined it with some other data, it can help to identify that particular person. So that is called as indirect PII. For example, date of birth, IP address, device ID. So if we take date of birth, so using date of birth only, we can't know who is that person. But let's say if we attach IP address, so there is some machine in the world where that IP address is tagged, which can be used by multiple users. But if we combine date of birth with it, so it can point to the right person, that this is the person who is using that machine with that IP with this date of birth. So that is how, like, indirect PII also, it is sensitive and important data. Next, let's understand why we need to handle PII data in a specific way. Why does it really matter? So one, it is data breaches are costly. So if somebody is able to steal our data and they are able to understand the data and use it for any purpose, harming our users or any illegal reason, so then the company, they have to pay the cost, and costs are very high for data breaches. It is in millions or sometimes billion also. And second reason, it is the regulatory requirements. So whichever organization are storing any PII data, so normally they follow some regulatory compliance which is mandatory for them. Like HIPAA, it is mainly in US. GDPR, it is used in Europe region. So like that, there are some standards that they need to follow and store the PII data in some very specific way. That is why it is important. And the third reason is reputational damage. So if there is any data breach or any personal data is leaked, so that the reputation for that organization, it is really hit, and users, they lose trust in that organization. So that is why it is again important to handle that. And this is an overview of PII data. And then there is something called as PHI data also, which is protected health information. What it means is that if there is some data related to health of any person, like medical records, blood reports, all these things, so that data is considered as PHI data. And if we take a simple example, so name and email ID, this comes as PII data. And if it is name and medical records or medical diagnosis related information, it is PHI data. So name, it can be on both side. That way we have some overlapping also. But what is important is that PII and PHI, both data are confidential and sensitive. So the techniques we use to store this data, it is like similar. So if we understand one, and in any project it is decided like whether it is PHI or PII, and accordingly the strategy is decided. So during rest of the demo we will mention only PII, so that we can keep it simple. But whatever is applicable for PII, we can same use for PHI. These are just other type of data and other columns technically. That's it. Next, let's understand the high level process of handling PII data. So there are multiple stages and multiple techniques. So let's go over these one by one. First one, it is minimize. What it means is that we shall collect and process only the PII data that is absolutely necessary. So depending on the project or business requirement, sometimes we really don't care about PII data. For example, if we have customers related information, so we can only ingest, let's say, customer IDs, their country and all, and the email and phone number, that info. If we don't need for analytics purpose, we can simply exclude those columns and we don't ingest them into our data lake, which is a simple approach, but important one. And we don't bring in PII data if it is not really required. The next part, it is classify. So if we are bringing any PII data, then we shall have proper classification of the data, that which column is PII or PHI and which one is not. And then accordingly we use tagging of the columns, mentioning like which column is PII or not. We will see that during the demo also. After we know which data is PII, then the next part comes is protect. So the PII column handling, we can protect that data using different techniques like encryption, pseudonymization, anonymization, and there are so many more. This is going to be the biggest part in our demo and explanation. So we will discuss in this one in so many more details. The next phase is control. So once we have stored our data, then we must control its access also. Who can see what? So that's where we can use column level masking and row level filtering depending on the role based access controls and all. So that's how we control the access. The next part, it is monitor. So in Databricks, whatever we are doing with PII data, so all the access related operations are logged into an audit table. So there we shall monitor who is accessing what data. We can even create dashboards there. And the last one is delete. So in normal analytics use cases, we don't need to delete the data, but there are some specific projects or organizations where if the, let's say, user is deleting his own account, then the underlying data also has to be deleted. So that kind of requirements are there. And if we have that kind of requirement, we shall be ready. We shall build our pipelines and code to delete specific users data whenever required within the specified time window. So we will see this, how we can achieve this. So these are the high level uh, steps or high level processes we do for handling the PII data. Now let's dig deeper into each of them, and then we will jump to the demo part also one by one when we understand each of this in detail. So first one, like we were discussing, minimize. So this one is like, do not ingest the tables containing PII if they are really not required. So which is very simple. We don't need to bring the tables if those are not needed. Second is that if you are bringing up the table, but from the table, if there the PII columns we need or don't need, that is something we need to decide. And if we don't need, so those columns also we can exclude in our ingestion process so that we don't have to handle PII data. And in terms of classify, so we can like add the right tags to the columns like PII, whether it is true or false, PII type, and classification. So depending on our need, we can create custom tags and attach them into the tables. And also Databricks, they have a latest feature where if we enable it at a catalog level, so it will automatically identify the PII columns and add the tags also automatically. So these things we will see in the demo. So now theory part, it is covered up to a level, and rest of the theoretical explanation of other techniques we will cover later. First, let's see the demo of minimize and classify so that we can understand how this work as we go over the item by item. Now I'm in my Databricks workspace, which is free edition. And these are the notebooks I have written, which are part of the repo. The link is there in the description. So first notebook, it is a simple one because we are doing this demo on the data. So simply we need some data that will be stored somewhere. So first of all, let's create a catalog. So this one, it is simply create a new catalog, PII demo. And within this catalog, we will create two schemas. So one, which we will use as a source of the data, because setting up really source and all, that is not much important from PII data perspective. So we will read from Unity catalog and write the Unity catalog as a target so that we don't have to make connections to external source, just to understand this PII part. So now our catalog is created. Let's create the source schema and then let's create the target schema as well. So our schemas are ready. Now let's go ahead and go to the catalog and let's create our source data so that we can start using that. So here is our PII demo part. And sometimes like it takes some time to show here. So either we can wait for it, or if it is not showing, what you can do is whatever other schema, or sorry, other catalog that is there. So here we can change the name. So that way also it will open if it is created programmatically, or after some time anyway it will be available here. But once I didn't notice that, so that's why I am sharing this technique. Now let's go to the PII source. So this is our schema. Here we are going to create our source tables. So for that we will go to create table, and here we will upload a file. So here are the three CSV files which I have included in the repo. So first let's create customers table. Let me upload this one. And it will start the serverless compute, analyze the data of CSV, and then allow us to create the table. So here we can see that this table, it is able to infer the schema and pick up the right column names. So it contains all these columns. So let's go ahead and create this table. So this table, it has been created. Now let's go back to PII source and let's create our second table. This time let me upload the employees CSV. This time it is faster. So let's go ahead and create this. This table is also ready. Now let's create our final table, which is going to be web logs. So this table also it is being created. Now our source data is ready. So let's go and try the minimization part first. So as I was explaining, right? So whenever we bring in the data, so the right way or like the in projects how we bring is like normally using JDBC URL or some other way how we connect with the actual source and then bring in the data. But after reading the data, we simply create a data frame and then we write it. So instead of going through the complexity of setting up a source, we will use the tables we just created as a source and create a data frame. After that, we will minimize whatever. After that, we will, while writing the data, we will do whatever we want to do so that it will work similarly as the actual source. So here what we are doing is we are simply reading that customers table. Then uh, this is where minimization is coming into picture, where we are selecting the column customer ID, city and country, which are not PII column. And we are not selecting any column which were PII, like name, email, phone number, all those columns we are not selecting. And why we are not selecting? Because let's say the current analytics we are targeting for this project or this requirement, that doesn't need those PII information. So for example, if we are looking for some kind of information like how many customers are there in each country, so that kind of analytics we can still get it without ingesting and handling any PII data. So this is how the minimized table looks like. So we have only these three columns with no PII data. And the analytics I was talking about, so still we can do group by and count the customers so that we know country wise customers. So this is a good analytics report. But uh, due to this minimization, we don't need to handle anything else in as a PII data or anything. So we don't bring in the data if it is not required. So that's how minimization technique works. Next one is about classify and tag. And in this one, what we are doing here is, let's say we bring in the entire table as it is. So here I'm simply reading the table and I'm creating the exactly same table in our target. So we are not making any changes there. And this new table we will use to apply tags. So the table it is written now. Let's check out its sample data as well. So here is the sample data and we can see that this table it contains PII data as it is. So how we can apply tag is it can be applied using SQL only. So this is the table like alter table, then alter column, which column we want to apply the tag. And here we are providing three tags like PII, whether it is true or false, and PII type, whether it is direct or indirect, and classification. So in PII, normally we use some common classifications like name, email, phone number. So that's where this also comes handy. So if we run this part, it will add these three tags to this column and to this table. So likewise, I have created multiple statements for each of the column, like email, similar information, phone also similar, SSN also like it is similar. So this is a date of birth, so it is indirect, and address it is direct, and next one city or city it is indirect, and the customer ID itself that is not a PII column, so that's why it is PII as false. Similarly, country is not PII, so that is also we are setting up as false, and the command it has been executed now. So let's go ahead and check out how these tags are visible. So if we go there and if we go to our target customer table, this is the table which is created. And if we see the definition of this, so here in the tags, we can see that whatever tags we have applied there, so those are available here. And how these tags can help is there are different ways. One, it will help in discovery. So whenever we want to search any PII related data, we will simply search the tag PII as true, and then we can get all the columns where PII is true. And that kind of queries we can run in the system tables as well. So if we check out the system table, so here we have that system table. So if this is our catalog, within each catalog we have this information schema, and then this is the a view that is available for all the Databricks workspaces. If we open this particular view, this will show us all the tags which are available for any of the column. So from here directly we can filter out like which all columns are PII, and which all columns are let's say having the static sorry the some specific classification, like which all name columns are there in our entire catalog, and whether the PII type direct or indirect, which all columns are there, which all tables they are linked to. So all this information it is logged, and that is how it helps really help in doing the discovery over it. And apart from discovery, we can use these tags to set up some policies at the workspace level. So depending on the policy also, the access can be controlled, which is called as attribute based access control. So that's how these tags they help. And in this current demo, we have applied these tags through our program, so that before we know what PII columns are there, then we apply that part. And recently, Databricks they have introduced a feature of their own, so that they can automatically detect which all columns are PII and then apply their own tags automatically. So this is the feature. Data classification is the name. So this feature, if we enable it in free edition, it is not allowed. But if we enable it, that's it. We don't have to do anything else. Inside those tables, it will automatically apply those tags, whatever they want to. And those tags are standard, so everybody can use them across organizations. Also, the same standards will be followed. This feature currently it is in public preview, and after some time it will be generally available. So this is all about classification and tags. Now let's go to our biggest section, which is most important also, which is protect. So protecting the data, it can be categorized into three different ways. One is called pseudonymization. In pseudonymization, what we do is we replace the original data with some different kind of IDs. And then we protect the data at the row level, because we process row by row in this technique. And re-identification of the original data, it may or may not be possible depending on the technique, which we will understand more when we will go to the demo and more detail. Second one is anonymization. So anonymization, what it means is we don't carry forward the entire PII data to our analytics layer. We prepared some kind of categories or some kind of summary over the data. That summary only we take it forward, which is used for analytics. We don't need the entire data set. And this kind of technique, it protects the entire data set, because row by row we don't apply a very specific technique. And in this case, re-identification, it is not possible. We can't get the data back from the anonymized data, which we will understand when we will see the demo. And the next one, it is encryption. In encryption, we encrypt the data using some keys. We store the encrypted data, and during retrieval of the data, we decrypt the data if required. And in this technique, re-identification, it is definitely possible. That is the purpose of encryption as well. And all these three techniques, they have subcategories also. So we will understand each and every one of them one by one. So first, let's see what is inside pseudonymization. So here we have two techniques. One is hashing, where we calculate the hash values of any column and then replace the data with those hash values. And examples are like SHA, MD5, these kind of functions. And if we do hashing, then the data is not reversible, because from hashed values we can't get the original data back. And second one is tokenization. So here what we do is we create a separate lookup table with original PII column values, and we replace the original PII column with some IDs which are available in the lookup table, so that if a person who is admin kind of person, then they will have access to lookup table, they can join and get the data back. And if the user is not up to the level to access that data, so for them we will not provide the access to that lookup table. They will only see the lookup IDs which we have replaced. So that's how like we restrict the access to that lookup table. Now let's go to the demo part, and first let's understand both of these techniques. So first of all, let's understand the hashing part. So here again, this is our source table, same table. We are reading the table, and here we are just printing some sample rows. So this is the same table. We can see that all the PII columns are available here. And this is where we are doing hashing now. So this is our original data frame. And here we are putting some expressions. So for customer ID column, we are selecting it as it is because this is not a PII column. Second one, full name, it is a PII column. So we are applying a hash function. So SHA2, it is the name of the function. It is taking our column name as input, and 256, it is the byte size, how much byte size hash value it will generate. So that is, and then we are giving the alias again with the same name. And to do the hashing, we have different functions available. Like this is one of them which we are using for full name. Email, we are using MD5. So this is another function which also calculate hash values. Similarly, we have SHA1 also. We have SHA2 also. It can take like this length also. It can vary 256 or 512. And this size here, it is bit, not byte, like I mistakenly mentioned here. So this is the like number of bit it will create. And it can also take like this as a length. So likewise, we have these different functions available for hashing, and they have their own pros cons. So some of them, the length is less. So if we have data in, let's say, billions, then maybe it is a chance that it can generate the same hash value for the some slightly different value. But normally that kind of collision we don't see. So MD5 also, it is fast in processing, and it is used widely a lot. But depending on our need, we can analyze them and then use whichever we want to. So here we are applying all those hash values. Country, we are not applying anything. And then after applying, we are just displaying three rows so that we can understand. So after hashing, here we can see that full name, it is creating like this length, 256 bits it is. Email, it is MD5 value. Phone number, it is the other one. Uh, yeah, it is SHA1, which has some different length. And for SSN, we used 512 length. So that's why this value it is longer. We can see here. So this is how the hashed value look like. These are very different from the original value. And from this value, there is no way to get the original value because this is a hash value, and there is no algorithm or the information from the original value that is lost here. So it is like for original column, a unique value only will be generated. But from this unique value, original value cannot be generated back. That is how this hashing works. And here, after reading that, we can simply write it into a table. And where we can use hashing is, so let's say we have some kind of scenario where uh, these column we may need for analytics purpose, like how many distinct values are there for full name, or if we want to join the full name in one table with full name in other table. So there, if we are using same hash column, then we will be able to join them. So that those kind of operations will still be possible. And the PII actual values we are not using. So that's how like we are handling the PII data using hashing here. And we can see that our final table, it is written with all the hashed values now. So this is all about hashing technique. Next one, let's understand the tokenization inside pseudonymization. So here again, we will read the same table first. After that, what we are doing is we will create a simple function which we will use it as a UDF, which is generate token, and it is returning a UUID, which is a unique ID generated randomly. So here we can see we are not taking any parameter. So this ID, every time it returns a unique ID. So that way we don't need to pass any column or anything like that. And then this function, we are creating it as a UDF here so that we can use it in data frame operations. Then here we are applying that UDF. So what we are doing is, so for this demo, we are using email column only to demonstrate how it is working, but same we can use for other columns also depending on the project need. So here we are selecting the email column, then applying a distinct so that for each of the different email, a separate ID is generated. And then for distinct emails, we are generating a new column which is named as token. And that new column value, it is coming from this UDF, which will be a UUID, which is generated randomly during the runtime. So let's run it and let's see how does it look like. So this is how the data looks like. For this email ID, this is the token it has generated. For each value, the token it is different and it is generated randomly. So this will work as a lookup table. So how we will do is, in original table, we will put this token value and use token only there. And this both this column, this will be stored as a separate table, so that that table we can control the access, and if somebody has access to that table, then only they will be able to read the data. So let's do that. So now what we need to do is, this is our source data frame original without any changes. Now we need to join it with this lookup data frame that we have created, so that we can replace the email with the token in this table. So here we are joining it based on the email. We are using a left join. We can use inner also. Both are same in this case. And we are selecting columns here. So all the other column we are selecting as it is, and only instead of email column, we are selecting the token column from the lookup table, and then we are renaming it as email token, so that the original value it is replaced with that token value. So this is how the data will look like. So email, it has been replaced with its token. So after understanding that everything is working fine, so let's go ahead and write the data for both our table. So this will be the original table which is tokenized now. This will be our lookup table. So the tables are created. So let's see the data inside them. So here we can see, so original data, it has been replaced as a token. So somebody who is not admin or who is not authorized to access this data, then we give access to this table only, and we don't provide access to this table. So that way we are able to segregate the PII data into a separate table itself, and then table wise access we can control. So if there is a admin kind of person, they can get access to both the table. They can join these table based on this token, and then they can get the email ID if required. So that is how this tokenization technique works. And this covers both the techniques of pseudonymization, which is hashing, and tokenization. Next, we will understand anonymization. So anonymization, it has two high level categories, which is data suppression and generalization. So data suppression, what it means is like excluding the PII column from the views and then providing dynamic access control. So on top of our existing table, we can create a view on top of it. And in the view, we can not select the PII column and then provide the access to that view. So this is a simple technique, simply creating a view on top of the table. And the second part, it is generalization. So generalization, it is again like it has different methods, which we will understand in more detail. So first one is categorical generalization, where we remove the precision from the data so that we are not able to map to that particular person or entity. And then we move from a specific category to something more general category, so that the data, it is no more PII, but the categories will still be able to help during the data analysis. So this is categorical generalization. Next one, it is binning. So binning, it means like replace the original data with some group values, which we will see. So for example, if we have a date of birth column, so instead of date of birth, we can say like some age groups, like this is the age between this, let's say 20 to 30, like that groups we can create in binning. Next one is truncating IP addresses. So this is very specific to IP addresses. So normally if we have complete IP address, so it is still possible to know which computer or which device is using that. So that becomes PII data, indirect PII data. But if we want to generalize that, then what we do is we remove the exact pinpointing information, and we keep the higher level information. So simply we have uh, multiple bytes in the data. So last byte, if we replace simply with 0, then it will not be able to tag to the right device which is using that IP address. But still it will be able to give high level information that which country or which region this data belongs, so that it will be helpful in preparing reports and analysis purpose without mapping any PII person. So this is very specific to IP addresses. And the last technique, it is about rounding. So if we have some numerical data, so instead of using that exact data, we can round the data up to some numbers and replace last 3 or 4 digits with zeros, so that overall the amount will still be visible. Like if it is a salary, so amount range, we will still get some right idea how much is salary, but exact salary up to the total digits we will not get it. So that is called as rounding. So now let's go ahead and check out all these techniques as a demo. Now I'm back in my Databricks workspace. First of all, we will understand data suppression. So here what we do is, let's say we have ingested some data, but that data we don't want to provide access to all the columns to all the users. So what we are doing here is, we are selecting only these two columns which are not PII column, and then creating a view here. And this view, it will have only two columns. So that way, if there are user who are not admin or the unauthorized user who don't need PII data access, so for them we will provide access to this particular view instead of the original table, so that they will be able to see only this data. And people who are authorized to view, we will give access to this entire table, though, so that they can check out the data. So this one, it is similar to minimization, but during minimization we didn't bring in the data into target layer. So here, simply during ingestion process itself, we didn't bring in the PII column. So in target we only brought in the required columns. But in suppression, let's say we have ingested this data. So this is the table which we created during our classify part. So we have this table, but this table, we are not providing access to all the columns. So we are creating a view, then providing the access. So that is how it is different from the minimization technique. Now, the next one we are going to understand is a categorical generalization. So here what we are doing is, as always, we are first reading our source table, and then we will be creating some general categories for the jobs. So let's say this is the exact job name, and this is some generic name we will create. So instead of calling any person software engineer, we will say that the job is engineering job. Similarly, instead of telling that it is exactly product manager or HR manager, we will simply say it is management. So these terms will be generic data. So that's how it comes under generalization. And this is categorical generalization, that the exact data we are mapping that to a particular category instead of providing the exact data here. So here this time we are reading the employees table, and then on the job title column we are applying this technique. So instead of these specific entries, we are providing these general categories, and then that generalized data we will be writing to our table. So here we are we are first renaming it. We don't need the job title column anymore. And then the generalized column, we are renaming that with job title. And then we are overwriting or like writing the data to our target table with the name categorical generalized. And then we are displaying the data. So this is how the data looks like now. So instead of the original data in the job title, which was a exact particular job, like whether it was HR manager or it was product manager, now we will see these general categories like management, engineering, and all. So this data is no more PII; it is generalized data, and based on this data, we can perform analytics we want without exposing any PII data. And other column, so I have not used any technique, because first we are understanding technique by technique based on simple single column, and then we will see which technique to choose, which is best, and then how to take a decision. So this is all about this one. Next, let's understand binning part. So binning is also a generalization technique. So it will be similar. Here we are reading our source table, again the customers table, and this time we are generalizing the date of birth column. So instead of providing the date of birth column into our target table, here first we are calculating the age based on the current date and date of birth, and then based on the age we are creating age groups. So if it is less than 18, we say under 18. If it is 18 to 25, then this is the age group which is created. And finally, we what we are doing is we are not selecting the age column, which is not required, and we are keeping only the age range column, so that instead of the date of birth column, we will see the age group, and based on the age group we can still do any analytics. Let's say this, for these age groups these many users are there, this is what we are printing here. So this kind of analytics is still possible, but we are not bringing in or using the PII data, the date of birth column data anymore. So that is how this binning works. So after understanding this, we are writing it into our target table, and here we can check out the sample data. So here we can see that date of birth column is not available anymore, and only this age range is available. So that's all about binning technique. Next, let's understand truncating IP addresses. So for this one, first we will be reading our web logs table, and then let's check out some sample data. And in this table, we can see that the columns are like this, like log ID, user ID, IP address, and all. So current focus, it is on IP address. So we can see that this is how IP they look like. And if we use this exact IP, so we can come to know like which device it belongs. So that is why this is PII data. So as part of truncating IP address, what we will do is this last digit or last value, whatever is there, we will replace it with 0, so that it becomes more generalized value, and then anybody is not able to map it to any particular device. And how we will do it, it will be a simple regular expression. So we take this column IP address, and then we are replacing the last digit by 0 using this expression. So let's see how it will look like after replacing. So here we can see that the last digit, it has been replaced with 0. And now we are good with the sample data, so we will write it into our table and then check out the sample data. So here we can see that the IP addresses, those has been generalized now. So these are more generic and nobody can know which device these belongs. Now the next technique and the final technique about generalization and anonymization also, it is rounding. So let's say we are reading the employees table here, and employees table, it contains some numerical data which is salary. And if we look at the salary column, we can see that this is available as exact numbers. So that's why this also becomes a PII data, because this is very specific to a person, how much is his or her salary. So that is where we will use rounding. In rounding, what we will do is we will replace the last set of digits with 0, and then the data will be rounded. So if we check it out, now in the sample data, let's check out the salary column, and we will see that last four digits, they have been rounded. So now this salary, it is not like any PII data. We know that somewhat it can still provide some category that any person's salary is in this range or something, but we are not exposing the exact salary anymore. So this is also called as a PII handling technique, which is rounding. So this is also used especially for the numerical column, so that based on these numbers we can still do any analysis like how many employees has salary greater than this, how many has less than this, with slightly less accuracy. But for getting summary kind of data, still this kind of data is very useful. So if we write this data and we check out the sample here, so we can see the salary, so it is rounded now. So that is how this rounding technique works. And with this we are done with the anonymization part demo. Next we will understand the encryption part. So encryption in general, it means that we can encrypt the data and store it in some like encrypted form, so that if somebody get access to that encrypted form, they don't understand the data. But if we know how it was encrypted, then we can decrypt the data and then we can use the data. So that is how encryption works. And there are different levels or ways of encryption. Mainly, there are three when it comes to PII data handling in respect of Databricks or general data engineering. One is column encryption. So this one, it is about like we take the column values, we encrypt the data using some encryption key, and then we store the data into the table. For example, we have this kind of function which can encrypt the data, and these values are reversible. So if we call the decrypt function with that exact key, then we will be able to see the original value, which we will see during the demo as well. And the next one, it is encryption at rest. So what it means is whatever data we are processing, so that data, it will be stored somewhere, right? So if it is like Azure environment, then it will be stored in ADLS, or in AWS, it will be in S3. Like that, for each cloud, there are different storages. And whenever they store the data, so they automatically first internal they do some encryption, and then only they store the data, so that if somebody steal that data, that they are not able to decrypt it automatically. And by default, they use their own like encryption key to encrypt the data. But if we want enhanced security, then we can provide our own encryption key as well there, which we will see how we can provide. So with that, the data where it is stored there, that also will be encrypted in its own form. And then the next one is about encryption in motion. So whenever the data is traveling, so let's say we are reading from the source and we are bringing in the data, or whenever we are doing any operation on the data, so it is being read from the storage location to the cluster, then back from cluster to storage. So basically, whenever data is transporting from here and there, so during that motion also the data has to be encrypted, so that if somebody intercept that communication, they are not able to understand the data. And for this part, encryption in motion, so this is very standard that they use some protocol like transport layer security and SSL kind of technique. So in this part, we don't need to configure anything, it is taken care automatically. And all the connections, those by default, they use these techniques to encrypt the data in motion. So now as we understand all these types, let's check out the demo for this column encryption and encryption at rest. So first of all, we will understand the column encryption. So here first we are reading the same customers table that we were using. So this is our table. Next, what we are doing is, this is where we are using an encryption key. And here I'm using this random encryption key. This can be any key, like we normally have password for our accounts, right? So this can be any key. And in practical projects or like the live projects, we don't hard code in the notebook like I have done here. So normally we store these values in the secret scope in Databricks, and then from the secret scope we read it and read here using the key name, and then the value is assigned dynamically. So that's how we used it in real projects. But here, for simplicity, I have put the value directly here. So this is the encryption key we will be using. And next part, like what we are doing is on top of our source data frame, customer ID is not PII, so we are selecting it as is. Then the full name column, it is a PII column. So we are passing this column to AES encrypt function. This is a very standard function which is widely used to encrypt the data. It is taking our column name as a input, and then it is also taking encryption key. This key also as input, so that using this key, it will encrypt the data and provide the encrypted value. And that value we will name it as full name only. So that is how we will get the encrypted value. Similarly, for all these other PII columns also, we are doing this encryption in exactly same way. And then let me display the sample data and see how the encrypted values looks like. So this is how the encrypted value look like. And as we can see, like reading this, it is nowhere similar to the original data, but it is different from the hashing or other keys that we used, because this data, it is still reversible in some form. It is containing the data as its internal encrypted way, so it is possible to decrypt the data, which also we will understand. So this is how encrypted data will look like. Now checking out the sample, we will simply write it into our target table, and then we will check out the sample of our target table. And here is the sample data, and we can see the all these PII values are in encrypted form. So now if we provide access to any user who is not really authorized to see this data, so they will be able to see only encrypted data, not the real column, but they will be able to understand that these columns are there in the table, and if they need access, they can request for it if required. And if we want to read the actual data back, then we have this AES decrypt function, like we have encrypt function. So in the decrypt function, what we are doing here is that we are reading the data from our encrypted table, and this is the column. We are passing this to our decrypt column. First, we are doing a unbase from 64, which is string decryption, and then we are passing our encryption key also here. After that, we are taking the value as string, and that will become our decrypted value as full name. This is the name we are giving. So if we call the decrypt function using the same encryption key, then we will be able to see the original value of the data. So like we can see here. So this confirms that whatever these encrypted values were stored, if we use the right encryption key with the right data, then the columns are decrypted successfully. And if somebody is using, let's say, any wrong encryption key, so let's say if I simply put here 123, then we will not get the right value. Here we see that it threw some error, and this is not like due to the encryption key. It is like that this key itself, it has to be something of very specific length. Currently we provided only 3 bytes here, so let's try passing some 16 bytes here. So to make it 16, let's use entire string. So these are 10, this becomes 16 now. So let's see if at least this value it is taking or not. And this time also it failed, and it is saying that the key we have provided, that is not a valid key. So that's how it is throwing the error, and we are not able to decrypt the data with any different encryption key. So if we will use the original encryption key, then only it will show the original data. So that's how like the data is really protected using this encryption key. And storing this encryption key is also like with same importance, because if we lose this key, then there is no way we can retrieve the data back also. So that's why these keys are stored very carefully in the secret scope. And in the current way, we are applying this decrypt function manually, but in real projects, like applying this on every column, it is not like user friendly, or like not a standard way also. or how we can restrict the access for some particular people without exposing this key. So there is another way we use this. So what we do is, here I'm creating a schema first, which is access control, new schema. Then for the decrypt function, instead of providing it as a uh, direct function or like using them as a column, we can create it as a UDF function. So here we are first defining the function here, that in this catalog, this schema create this function, and this function, it will be taking a encrypted value as input, and it will apply the decrypt function in itself and return the decrypted value. And now this function, it will be created as a entity in the Databricks, and we can control access to this function. And then once this function is ready, then instead of calling that entire decrypt function here, we simply call this user defined function here, and then we pass our full name, email, all those columns, and then we get that as output. And this function, somehow Databricks is not able to point directly or identify automatically. That's why it is showing these red lines, but in real it is working fine. So it is some limitation here. So we can see that using this custom function, we are able to decrypt the data. And this function that we created, let's see how it looks like. So if we go to our catalog, and then here, this is the schema which has been created, and we can see it is registered as a separate function here. And this function statement we can see along with the different other information. And also we have this permission section as well, where we can grant access only to some specific users and not provide to the users who are not eligible to see this data. So that is how this encryption part, it works end to end. Next, we will understand encryption at rest, how it works. So here I have a Azure account, my own account. I have created a storage account here. So if we go to the storage account, then in the network and security, we have this section encryption. And currently we can see that it is encrypted using Microsoft managed keys. So it is using its own key to encrypt the data. And if we want to provide our own key, which are called as customer managed keys, CMK is the short name that is used. So that also we can provide it. So what we need to do is the key that we have, we store it in a key vault, and then here we select that key vault and the key name in the key vault, so that that key it will use to encrypt the data whenever it want to, instead of using Microsoft managed key. So this is how we can use customer managed key to encrypt the data at rest. And with this, we are done with the demo for encryption part. So next we are going to understand the control part. So control is all about controlling the access, whatever we have the tables or schemas. So there are these 4 points majorly which we shall be aware. So one is role based access control. Like we have created different AD groups, like group of users, developers, testers, business users, analysts. For them, we create different uh, group of users. Those are called AD groups or intra groups, and those user groups we provide some access based on their role. So that is called as role based access control. Second is attribute based access control. So based on the attribute, it means tag. So during our tagging part, we saw that how we can apply tag to some columns. So based on those tags, we can create some policies, and then we can control the access also from there as well. So normally this attribute part, it is normally done by admin people. So I will not be able to demo this part. Next one is row filtering. So if we have a table, then depending on the user, which user group he is coming from, we can apply some row filter to display or hide some data. So we will see this during the demo. And column masking is, we can apply masking on the column values depending on the uh, type of the data which is there. Like for name, email, phone number, we use different kind of masking which we will see. So depending on which group the user belongs, the column will be masked. So role-based access control and these two are used as a combination. So because the user groups, that is part of the role-based access control only, which we use in row filtering and column masking. So let's check out their demo now. So now I'm back in my workspace, and let's say I have this customers table. So if we go to the permission section, which is here we can grant access based on the user groups. So let's say if we have created two group, one is admin, one is let's say business analyst or whatever. So here if we select the admin group, which currently I have not created any groups because that is a tedious process done by the admin teams. But let's assume we have two groups, admin and business analyst. So here if we select admin and then if we select all privileges, so then admins, they will get access to do anything in the table. They can see the data, they can delete the data, they can do whatever they want to do. And then let's say we select the analyst group here, and for them we don't provide all privileges, but we provide select privilege. So it will give only read access to those user group. It will not provide any access to modify or delete the data. So that is how, based on the group of the group, which group user belongs, they will get the access dynamically. And this is called as role based access control. And this access, it works this general role based access control, it works until catalog level, schema level, or table level. Everywhere we can apply whatever we want to control. And if we want to control within the table, like at the row or column level, that is where the combination of row filters and column masking comes into picture. So if we go back, first let's understand what is column masking. So let's say here we have ingested the data into our customer's target table, which is like the original data without any modification. So that's how we are storing the data here. We can see the data is visible as it is. Next, what we are doing is we are creating a function to apply column masking on the full name column. So this is the name of the function, which can take any column, and it will return a string, and the value it will return, it depends on this condition. This condition, how it works is, if the user is part of this group, like is account group member, like if the account which is currently being used, so if I'm currently running this query, so it is like this is the username, my username. If this username is part of the admin group, then it returns name, like it returns the original value. And if it is not like the original, not original, not part of the admin group, then what we are doing is, we are from the name we are taking only one character, the first left character which is there, and then we are uh, concatenating it with star star star. So for example, if this is the username, so the other than admin users, they will see s star star star. That's how they will see the data. So this is a masking function, and depending on the role or group of the user, it will decide what to show there. So if I run it, currently it will just create the function, not do anything on the table. It is just creating it as a function, and the function is registered in our catalog. So if we go to the catalog and if we go to this access control part, we can see this mask full name. It is currently registered as a function based on the definition that we had provided. And next one, we are creating another masking function for email. So for email, we are using a different technique. So we will see like what this is applying, how it is applying on the email, what exactly it is doing. Then for phone, we are using a different technique. So in general, the technique is same. If it is admin, then return the entire thing. If not admin, then return the data which is masked. So what masking we use for email, we replace something different with star. For phone, we replace it with something different. We can use something common as well. but there are some common practices which are followed. Based on that, I have created. So let's say this is for SSN, this is for date of birth, this is for address where we don't show anything, everything we replace it with stars. And then this is for city part. Now, as we have created all these functions, so these functions as expected are registered here. If we go here, we refresh this page, then we will see those functions. So here we can see all these functions are created. But so far, because these functions are not attached to any table or any column, so they are not yet effective. To make them effective, what we need to do is we need to apply these masking function on those columns. So this is the statement that is used to apply that part. So for example, here we are doing alter table. This is the table. Alter column. This is the column. Set mask. So this is the mask we are applying, and this mask, it is the function that we had created for column name. So that is how the link between the function we create and the table and column works. So for full name, we are applying the full name masking. For email, we are doing on the email column the email mask. So that's how for each of the column we are applying these different masking functions. And after applying all the masking function, now let's check out the data. So here if we see the data, so we can see that it is coming in the masked form. And the masking, it is working different way for different columns. So for full name, like I explained, we keep only one character, replace everything with the star. In email, we keep first character, and then like we remove everything before at the rate. And after at the rate, we are keeping it because this is not PII information. For phone number, we are only showing the last four digits so that some idea we can get without exposing exact information. For SSN number, we are showing it this way. For date of birth, we are only showing the year column, not the month and other part. For address part, we are not showing anything at all. For city, we are showing only two characters and not showing the other part. So why I showed all these different functions is that because there are different ways of masking. Depending on what definition we are providing here, accordingly the value will be shown. And why I'm seeing the masked values and not the original values is because currently I have not created any user groups, which we can't create in free edition. Otherwise, I would show it. But because I have not created any groups at all, so if we understand this condition, so my current user, which is this ID, is it part of admin group? No, because there is no such group also. So that is why it is going to the else part and showing me masked value. And if we reverse this value, this if we put in the admin part and original value if we put below, then my user will be able to see that value. So that is how like this masking works. And this is like column masking plus role based access control, because depending on the user group, we are deciding what to show or what not to show. Next, let's understand the row filters, which are similar to column masking, but they work in a different way. So in here also, first let's see the sample data from our original table. Here, let's first start by checking out the same sample data. By now I know you remember all the data. And here we are seeing this masked data because we just applied the masking, but now we will combine it with the row filters as well. So for the row filter, the technique is like I was saying similar. So here also we create a function. It will be with this name. It will take a input string, which here we will be providing as a country name. And this is where the difference will come between row and column. So in column masking, we were not applying any filter, but here it will be a filter. It will be returning only true or false, no other value. And if it will return true, that means that particular row will be visible to user. If it returns false, then those rows will not be shown to the user. So how it is working is, so if let's say the user who is currently running this is part of manager group or admin group, we can mention any name, then true. That means managers, they will be able to see all the rows. After, if the user is not part of the manager, then if the country is India, so it will go row by row. And if the country value, if it is India, then true. It means like for rest of the users, it will be able to show the rows where country is India, and else it will be false. So if user is not part of the managers group and wherever country is not India, there it is returning as false. So those rows will not be visible to the user. So if we run this, this will also be registered as a function in this schema in the same way. And how it will be applied, so that is slightly different. So this time we are altering the table, and instead of setting the column mask, we are saying like set row filter. So here we are mentioning the filter function that we just created above on this particular column. So on country column, it will apply this filter, and based on these conditions, it will show the data. So let's alter it, and then we will be able to see the data. So if now I query the data, so now we know that because we have not created any group as of now, so I'm not part of this group. And so I shall be able to see wherever country is India, and other countries I shall not be able to see. So now if I'm querying the data using my user, so we can notice that wherever country is India, so out of all the 1,000 rows, only 141 rows has been returned where country is India. Otherwise, like other rows are not visible. And before applying this row filter, when we queried the same table, so we were able to see all the countries data. So that is how this row filter is working. And if any user who is part of manager group, they will try to query the data, so they will be able to see all the rows. And for the column part, so it will depend on whether they are part of admin group or not. So that is how it can be used in a combination as well. So this is all about role-based access control, like generic access control on table level and all. Also column masking and row filters, how this work. Now let's move on to our next section, which is monitor. So monitor, like the name suggests, it is about monitoring about the access, who is accessing what. So for that purpose, we have very detailed access logs are available in this particular catalog schema and this table, which we will see right away. And based on this auditing information, we can create any dashboard also, like who is accessing what. So that way it becomes very much visible and able to track who is accessing what kind of data. So monitoring, again, it is very, very important. So if we go to the Databricks workspace, here in the catalog section, we all have this system catalog which is there. Some for free edition it will be visible, but in real projects it may or may not be visible because its access it need to be provided separately. So within this system we have this access schema, and then we have audit table. So whatever a user is accessing, everything is logged into this particular table. So like which account, which workspace is being used, which version of APIs it is using, exactly at what time it is being accessed, what is the IP address from where it is being accessed, what is the agent which is used, and then user related information is also logged. So like that, we have so many different operations, like which service is being used, what action user is taking while doing that event. So like that, there is so much more detailed information available. So right now we will not be focusing on this because this is normally done by admin people, and it can also be go into so much more detail. But what I wanted to showcase is there, whatever operation we are doing in Databricks, everything is logged here properly, which can be monitored in a very granular level. So that is how monitoring can work. And admin people, if they need it, they can even create a dashboard on top of this table to see some kind of summary or latest information. Now coming to our last section, it will be delete. So whatever process we are building, if we are handling PII data, there has to be a very standard process of deleting the data as well. So it may depend on the organization. So some they may not need to delete the data, but some organization they have some very standard compliance where they have to delete the data for a particular user. For example, if we have created our account on any website, right, like Facebook, Instagram, or Gmail, whatever it is, and if we go ahead and delete our account, so internally they have compliance that within, let's say, 7 days or within 30 days, all the underlying data of that user has to be deleted from all the systems. So this is also part of PII data handling. And there are like only two major points, that all the tables which we are creating, those must support the deletion. There has to be a very standard pipeline, and regularly we need to run vacuum commands also to delete actual data from the delta table. So this part we will now understand in more detail using our demo part. So now I'm back in my Databricks workspace in the final notebook. So delete a command, it is simple, like delete from table where, let's say, employee ID is 2. We can use any table for demonstration. So I'm picking some random example. But before we run this another point is more important to know. So normally we use only delta table into Databricks to store the data in the latest tables, which are silver and gold. So there is this property in delta table which is called as delta dot deleted file retention duration. So as the name itself suggests, so if we run this delete command, then the actual data from table it will not be visible, but delta it has a time travel capability. So it will still be able to show the old data. So that in the older version of the table, for how much time we want to retain the data, so that is where this property comes very handy. Its default value is 7 days. So whatever data is deleted 7 days ago, and if we vacuum the table now, then the older data will also be deleted and no more accessible. And for some organization, we can change it to 30 days depending on their compliance time. So if I run this command, it will change it to 30 days. This one is just to showcase that this property works. Then we are going to delete one record from our table. So if I run this command, it is going to delete this particular single record from the table. And here we can see that one record has been deleted. So if we query the table simply based on that employee ID, so we will see that the data is not visible anymore. But due to the delta time travel thing, the real data it is still not deleted and it is still accessible. So let's see how. If we do a describe history on the table, it will show us the previous versions of the table. And here we can see that 3 versions has been created. So first of all, we just created the table, then we set that property in the first cell, and then we ran a delete operation. So in the version 1 of the table, the data would still be available. And if we query the data from this version of the table, one version, then we will be able to still see the data. So here we can see that record it is still existing even though we ran the delete command. And that is where the vacuum comes very handy. If we run the vacuum command, then what it will do is it will uh, actually delete the files which are deleted uh, 30 or more days ago. So depending on this property, if this many days has been passed after we deleted the data, then it will vacuum the data. It means it will flush out the data entirely. It will not be accessible anymore. So in current example, it is 30 days. So right now it has not done any vacuum. But let's say after 30 days, if I run the same command, then it will actually purge that data and remove it completely, and the data will not be accessible anymore. So that's why a deletion itself will be supported, and vacuum also it has to be run at a decided interval so that the data is deleted properly. And in real projects, what we do is we build like deletion pipelines separately based on like a user operation or user ID. If we have to delete some data, So it will delete the data across all the tables. Let's say based on any customer ID, if we have to delete it, so then we build the pipeline that delete the data for this customer ID from customer table, from transaction table, wherever the data is existing, it will delete the data from everywhere. And finally, it will also run the vacuum command as well, so that if the previous deletions they have passed that 30 days or 7 days threshold, that data will be vacuumed completely. So this is all about deletion. And now we have covered all the techniques which are there. And I know by now you must be confused. There are so many techniques. So which one to use and how do we decide which one to pick up? So let's check that out. So to make the decision on the PII approach, we ask some question to ourselves or to the customer, whoever is handling that data. First question is, do you really need PII columns in data lake, or you don't even need those columns, right? Like we saw the operation. So if we the answer is no, that they don't need all those PII columns, so we will use the minimize techniques and we will exclude the columns during ingestion. So the columns itself are not ingested and we don't need to do any PII handling. And without those columns also, we will be able to do our analytics whatever is required. And if the answer is yes, that the data is required to be ingested in some form, then the next question comes is summarized or aggregated data enough to do the PI, to do the analytics whatever we need? If the answer is yes, then we will use those generalization techniques like we used for date of birth to the age conversion, age group conversion, or we used the job title to higher level job categories. So if those summarized data is enough for the analytics we are doing, then we will use for generalization. And if the answer is no, that summarized data is not enough, that means that data again we have to bring in some other form. So the next question we are going to ask is only hashed irreversible data enough? So if we need that data, so is only hash key is enough, generating the hash key which are not reversible, so that we can still see their distinct values, we can join tables. So is that kind of operation enough? If the answer is yes, then we will be using the hashing technique. We will store the hash values, which is irreversible operation. And if the answer is no, that hash values are not enough, then we will ask our next question, which is, do you want to segregate PII data into separate table, or keep the data into the same table and do some handling there? So if the answer is yes, we want to segregate only the PII data into separate table, then we use the tokenization technique. So in tokenization, if you remember, we store the lookup table as a token and real value into a separate table. And the original table, we replace the PII values with the token values. So then we use tokenization that way. And if the answer is no to this question, then next we ask, like, do you want to store encrypted data and control access to the keys? So is the requirement like we want to store the data as it is, but in an encrypted form? Then what we do is we use the column encryption technique that we used like AES encrypt and decrypt function, so that the data is stored as it is, but in encrypted form. And if the answer is no to this question also, then the next scenario comes is like, if you want to store the data as it is without any restriction, without any encryption, you want to store the data like without any modification, but you want to control the access based on the role of the user. So then what we do is we used role based access control. So we can use it table level, we can use those row filters, column masking like we saw. So all those we can use here. So these are all the questions we need to ask and we need to decide the technique. But the last point we shall be aware is that we shall be open to use combination of these techniques as well. So depending on the need of the user, so for some data, some column, we will be use, let's say, generalization. Some data we may do hashing, that is enough. Some data we need to store it as encryption, role based access control. So table level it is always will be there, and role column we need it or not. So depending on that we discuss each and every requirement for each and every column, then only we decide for each column what we shall do. And for each column also more than one technique can be used. For example, even if we encrypt the data, still we can use role based access control there. So this is how we decide which technique to use. I hope it is more clear now after understanding the techniques, the technicality of it, and then how to make the decision which one we want to use. So now you go ahead, you implement all these techniques yourself, because only after implementing you will understand them in the real how it works, and then only you will get the confidence that you can use that technique. So that's why I have provided all the material. You go ahead, you implement everything, and still if you come across any doubts, then put them in the comment section. And if you appreciate this effort I have put in here, please put a like and comment on this video so that other it can reach out to others also, and they will also be interested to check it out. That's all for now. Thanks for watching. Thank you. Bye bye. Happy learning.